then they're saying here, okay, well, if AB squared is less than AC squared plus CB squared, then I know I have an acute triangle. And what do you think the last one is? Obtuse. Okay? So we're going to use that idea a little bit and work with it. So turn it over. All right. So classify the triangle with the given sides as right, acute, or obtuse. Well, I'm always going to have the longest side by itself, and I'm going to add the other two together. Okay, so I'm going to just checking to see, is 8 squared equal to, I'll just put this here. I don't know what it's going to be. We'll find out. 4 squared plus 4 times the square root of 3 squared. I'm just checking to see what's going to happen here. 8 squared is what? 64. What's 4 squared? And then do this in your head. 4 times 4 is 16. Square root of 3 times square root of 3 is what? 3. What's 3 times 16?
9. Oh my God.
Okay, so let's keep going here. 64, oh, this is also 64, so they're equal. So what kind of triangle do I have? Okay, let's do another one. I'm going to do the biggest number by itself. I don't know what's going to go in here. 10 squared plus 11 squared. That shouldn't be there. Okay, so let's find out what happens when we do this. 14 squared is 196. This is 100 plus 121. You can see what's going to happen. 221. This side is bigger. So the two sides added together are bigger than the third side, which means it's a what? Do you remember? Two sides added together are bigger than the third side. Let's look at it this way. If the third side is smaller, it's what?
Cuter.
Cuter. It's acute, okay? If the third side is bigger, it's what? Obtuse, okay? All right. I bet you're going to think this is obtuse, aren't you?
I think it's straight.
That'd be too obvious. Let's just do this. Square root of 61 squared. Let's find out what happens here. This is just 61. 25 plus 36. Oh, what's going to happen here? It's right. Yeah. So remember, if the third side is smaller, what kind of triangle is it?
Acute.
Yes, and if the third side is bigger? Obtuse. Okay? All right. Now, this one here, we have to go back to something that we learned before, last semester. Can the segments with the lengths of those side lengths form a triangle? So the first question here is A, and this is B. We learned something called the triangle inequality theorem to determine whether something can form a triangle. Do you remember what that theorem was? It's nothing to do with squaring. It's just checking something with the side lengths. No squared. It's not the Pythagorean theorem. The triangle inequality theorem was, if you add two sides together, they have to be what? Bigger than the third side. So you have to check all the combinations to see if it can form a triangle first. So we're going to check all the combinations to make sure it does form a triangle first. So we'll do 11.2 plus 6.5. Is that greater than 7.1? Yes, it is. Okay? And then you do the other combinations as well. You could do 6.5 plus 7.1. Is that greater than 11.2? And when you add them together, that is 13.6. And yes, it is greater than 11.2. So that one works, that one works, And then the last one, you would say 11.2, which is kind of obvious, plus 7.1. Is that greater than 6.5? Yes. So it does form a triangle based on the triangle inequality theorem. So we'd say yes. And then we determine which way, what it is. So for part B, I'm going to say now 11.2 squared, and then I'm going to do 6.5 squared plus 7.1 squared. This is 125.44 and 42.25 plus 50.41. You can see what's going to happen maybe. This is 92.91. So the third side is greater than the other two. So what is it? Obtuse. Are you good with that? Okay. So I'm not sure if this recorded properly. So here's the theorem here, based off these pictures. The third side is smaller. The square of the third side is smaller than the square of the other two sides, then it's acute. If the square of the third side is bigger than the square of these two added together, then it's an obtuse triangle. And here we just checked what they ended up to be. This was a right one. This turns out that the third side is smaller than the other two added together, squared, so that's acute. And this turned out to also be a right triangle. For this one, in order to answer the question, we had to use the triangle inequality theorem, which we learned last semester, to check to see if it really was a triangle first, and it did qualify as a triangle. For that one, you just add the two sides together, and it has to be greater than the third side. And you have to check all three sets. Once we determined it was a triangle, then we used the squared to decide whether it's an acute, an obtuse, or a right.